Top of the morning to you, ladies and gentlemen. And I welcome you all again to this fascinating panel session 3, which is on nuclear energy, as I recall it. And for those of you who may already know me, I am Kune, Y-S-U-H. And for those of you who may not know me yet, I'm still Kune Y, so. And better known as SKY or Sky for short. Okay. Um, my dress code, casual, maybe a little too casual, but this means I'm in business. Okay, so let's get it to this panel session. And believe it or not, I've been teaching nuclear engineering and I've been preaching about nuclear energy for 30 some years. And I've got a daunting task this morning of hashing out a wide spectrum of nuclear issues, starting from the drawing board all the way to safety, security, as well as safeguards, including non-proliferation. Okay, and I'm apparently honored to and humbled to present to you my dream team of 3 panelists. Actually, it's about time to switch to my presentation material over here a little bit. Is it okay? Is it connected? Hopefully. Anyway, in the meantime. Okay, so buckle up, sit back and relax. It's showtime. Oh, by the way, as far as my presentation, I got both good news and bad news. Bad news is that I scanned through all those materials last night, and it looks like my material is kind of overlapping with one another. So I just chose to take out all the materials that are written out in the paper. And good news is that the remaining is really just motion pictures or videos, so really it's showtime. And this morning I'll be playing a different kind of CEO, which is Chief Entertaining Officer, so please bear with me. All right, let's start with nuclear fission because actually, okay, as far as nuclear reactions are concerned, we got 2 kinds, fusion versus fission, but this time we'll be basically talking about the fission only. Splitting of the atoms, okay? And as you could see here, this is a different kind of mechanism. It's not chemical, it's not mechanical, but it's nuclear. And that means we're not consuming any oxygen, we're not producing any CO2. And as Albert Einstein has alluded to some 50 years ago, maybe more than that, this is one heck of a way of boiling water. And this way we can boil water and then turn the turbine and make electricity all the way to here, for example. So as far as our session is concerned, I will be basically restricting our talks within basically 15 minutes. Okay, so I'll be actually warning you 10 minutes into presentation, and then 15 minutes maybe I might be yelling at you. Okay, so keep that in mind. Anything else? That was fission, nuclear chain reaction. There's another one that has to be dealt with in this session, and that has to do with production of plutonium. And that's not necessarily fission, but it's a capture. And uranium-238, which has been mined from Earth, could be transformed into plutonium. And that has to do with a lot of nuclear non-proliferation, as well as safeguards. And I believe that probably Roger Cashmore is going to cover this, okay? So as I said, let's get into virtual engineering. As far as this virtual reality is concerned, in fact, sky's the limit. So again, let me see. So what I'm going to really do this morning to walk you through this nuclear power plant. Actually, this almost a real plant, even though it's virtual, and that is situated in the Ulsan site. And this is what we call, used to be called Korean Standard Nuclear Plant. Now it is being called OPR 1000, which is Optimized Power Reactor 1000 megawatt electric. And we are actually utilizing this technology to really enhance from the conventional drawing board to the 3-dimensional space so that we can actually walk through this before this could be constructed. And this is one heck of a way of trying to see what it is going to look like and how it's going to behave, including the main control room. And if this kind of setup is ready between the countries, between the organizations, then the international collaboration, or as far as crisis management concerned, becomes a reality. We are going a step further, actually maybe several steps further, to realizing this international global collaboration as far as this safety, safeguards, and security are concerned. Again, this like my laptop, and it can actually more than whole plant. This again, the whole plant, not just primary system, not just secondary system, but everything you can imagine as far as nuclear power plant is concerned. And we can actually, I'm sorry for these Korean characters, but this is Korea after all. So we can just check out all those components and systems and structures and buildings and subcompartments, you just name it. So this is just a brave new world, which could be utilized to setting up this international collaboration as far as nuclear safety and crisis is concerned. Okay, so as far as this is concerned, we can just do so. And I believe this may take half an hour. So let me just skip over to next one, okay, and see what I got here. Let's see. Again, this is a new dimension as far as nuclear power is concerned. As I said, it's very simple. If you come to a nuclear reactor, it's about nuclear fission, which generates heat, and we need to take this heat out. And as far as this water-cooled reactors are concerned, the only way to do so is putting in water at the right time, at the right place, by the right personnel. Okay? If this is not done, then we go into trouble. And this is part of the story that really ruined Fukushima several months ago, because they could not really put this water on time at the right place. And this kind of technology could be utilized to really improving the safety and actually the degree of safeguards as far as a nuclear system is concerned. And we need to do our homework because as far as one nuclear power plant is concerned, we're talking about one drawing after another. And think about it. We need to talk about almost 500,000 drawings. It's more than enough to fill this whole room. Okay, so the only way to quality control and quality assure these drawings is to go through this kind of electronic engineering. Then we can talk about nuclear power safety, nuclear power operation, maintenance, decontamination, decommission. We'll be talking the whole life cycle for this matter. So this one technology, again, this like a transition from the traditional drawing or conventional design over to the advanced technique of virtual design. It's like a building Airbus A380 on a virtual reality technology, for example. Okay, if this is done, then we can do a lot more things. Public relations and explanations, and looks like he or she or it is trying to speak something. Actually, he's trying to speak about how to generate electricity out of the pressurized heavy water reactor. It's pretty tough because normal PowerPoint material cannot really do the job. And that is it. We do not need many language. We don't need many words. We can just sit back and relax. This goes through all its own and then talk about fission, heating, decay products, etc. By the way, there's one thing. Even if we can shut down the reactor, the nuclear reaction itself stops. But the materials continue to generate heat for quite a bit of time, maybe several months or even years. And the radioactivity like alpha rays or alpha particles, beta particles, gamma particles, or even gamma rays, that can be generated even centuries or even millennia. This is where we are running into trouble, radioactive materials. So we need to be thinking about security, safeguards, and safety at the same time. So we need to kill several birds with one stone. Again, this might take a little bit too long, so maybe we can have the liberty of skipping over to next graph here, okay? And Again, I thought that this session was about safety, crisis management, disaster management. So I chose to show you some, there's some typo here. It's supposed to be virtual, not virtual. But anyway, uh, this kind of a virtual reality plan could be utilized to check on the safety, security, safeguards again, and check on all different kinds of systems, subsystems, pipings, structures, etc. Check on temperatures, pressures, humidity, radiation levels, everything you can imagine as far as nuclear power is concerned. So this nice tool to possibly utilize in checking out the safety, okay? And this could have been used in Fukushima if they had one, just to see what might be going on in the plant, because more often than not, we cannot really have an access to the plant at the time of the accident or at the time of crisis, we cannot have an access. This is a tool that could allow us to check around. And as far as I know, this is the state of the art as far as the 3 Mile Island Unit 2 is concerned. The best picture or type of video, and that is checking on the initial cause starting from the turbine building, basically, and then sequence of events, and then turning into feed water side, and then steam generator, back to the primary system, steam generator, and then covering the reactor vessel. And it's not a simple video. It's connected to physics, because we need to be talking about physics at the same time. Physics-based, principle-based video. So it's connected. So we were relying on a code named MEF4. That's actually used to be my baby. I used to work for Westinghouse, and at the time, I was writing up a severe accident analysis code for boiling water reactor code. And this is what had been used to utilize not just the boiling water reactor, that is the case of Fukushima, but also 3 Mile Island Unit 2, which is pressurized water reactor. Okay? So it looks like I'm a little over my time. Let me try to finish up Fukushima just a little bit, and then I'll be done, basically. Okay? Maybe I don't need any more. This means Fukushima Daiichi plant. Blah, blah, blah. And then next one. Let's take a look. Actually, we were lucky, or they were lucky, that they could avoid this disaster, steam explosion. Once the material is molten, then there's a possibility, big possibility, that the water that is being injected, in this case could have been seawater, might be exploding, because we're talking about vapor whose volume is 1,000 times greater than that of liquid water. So that could have led to explosion, but they did a fairly good job, and we all avoided this last disaster.